Hey, welcome to The Explainer. Today, we're looking at a tiny drone that could totally shake up the world of robotics. And you know the craziest part? Its design inspiration comes from something you've probably seen 1,000 times, a little piece of natural engineering. So let's get into it. So let's just start with a question to get you thinking. When you picture a high-tech drone, you're probably thinking about a marvel of complex engineering, right? But what if the absolute best, most efficient design wasn't actually invented in a lab at all? What if, instead, it was perfected over millions of years by this, the Samara seed? You've definitely seen these. We call them whirlybirds or little helicopters. And as they fall, they do this incredible, mesmerizing spin. That spin is called autorotation, and it's what lets them glide for huge distances and land super gently. It's basically nature's masterclass in flying efficiently. And that masterclass, well, it's what sparked an incredible breakthrough in technology. Researchers are calling it the drone seed. A team over at Singapore University of Technology and Design, they took this brilliant natural design and built a microdrone based on its exact principles. And what they found, which they published in IEEE Robotics and Automation Letters, is, well, the results are honestly staggering for a drone this tiny. So, just how light are we talking? 32 grams. I mean, to give you some perspective, that's literally lighter than a single slice of bread. It's almost weightless. Now get this, that tiny 32-gram drone can hover under its own control for 26 minutes. For something this small, that kind of flight time it's just wild. It's almost unheard of. So the big question is, how on earth is that even possible? Well, here it is. Here's the secret. 1. It pulls off this incredible performance with just a single motor. Not 4, not 8, just 1. And that isn't just a minor detail. It is the whole key to this revolutionary design. So let's get into the principle of why this less is more approach works so ridiculously well. This isn't just about making something lighter. It's a completely different way of thinking about how to build tiny flying machines. And it all comes back to that one principle we saw in the seed, autorotation. The drone's single wing spins, and that spin itself generates lift. So the motor's there to get things going and provide thrust, but the actual shape of the wing, that's what does the heavy lifting. It creates this super stable, incredibly efficient flight without needing a ton of power-hungry motors to keep it balanced. And you can really see the difference here. Think about a typical micro-quadcopter. It's all about brute force, right? It's got 4+ motors constantly burning energy just to fight gravity and stay stable. But the Samara monocopter, it's designed for what's called intrinsic stability. It just works with physics, using its one motor and its smart design. It really is a story of elegance versus effort. And that quote really nails it. This is a huge strategic shift. Instead of just throwing more power and more hardware at the problem, this whole approach is about trading in that brute force for smart design and a real understanding of flight physics. Okay, so the science is awesome, no doubt about it. But how do we actually get this thing from a cool experiment in a lab to something that's useful out in the real world? Let's take a look at the road ahead. First things first, let's get a reality check. On the official NASA scale for technology readiness, the TRL scale, this drone is sitting at about a 3 or 4. Now that means the concept works, it's been proven in the lab, but it's still a long, long way from TRL 9, which is when a product is actually ready for the market. So what's that journey probably going to look like? Well, in the next year or two, we might see it used for things like indoor inspections or checking air quality in specific spots, controlled environments. Then, maybe 2 to 5 years out, you could see it in more niche roles, carrying super light sensors for universities or civil defense. And then, if all goes well, we're talking 5, maybe 10 years plus before we see it being widely used in big fields like precision farming. But of course, that path is anything but guaranteed. There is a whole gauntlet of very real challenges that this tech needs to get through before it ever leaves the lab for good. And you can really break these challenges down into 4 big buckets. You've got the basic engineering and science problems, the systems and power puzzles, the whole maze of government regulation, and then, the simple economics of it all. Will people actually buy it?
All right, let's dive into the technical stuff. First big question, wind. It's great in a lab, but can it stay stable outside when the wind picks up? Next, manufacturing. These things have to be made with incredible precision to work right. Doing that cheaply and on a massive scale, that's a huge challenge. And finally, sensors. I mean, a drone's not very useful without a camera or a sensor, but you have to add that payload without completely killing its amazing flight time. And the non-technical problems are just as hard. For it to be easy to use, regulators have to agree that it's a low-risk drone. From a money standpoint, it has to be cheap enough to actually compete with all the lightweight quadcopters that are already out there. And maybe most importantly, it has to be simple. Someone needs to be able to pick it up and use it without needing weeks of special training.
So if you want to boil it all down, the entire future of this drone seed really depends on three things. Can it conquer the wind? Can it navigate the bureaucracy? And can it win on budget? So, if you're watching this space, what are the key things to look for over the next year or so? I'd say there are three signs of real progress. First, we need to see outdoor demos in real-world wind. Second, they need to release some pre-series prototypes with clear specs. And third, we need to see pilot programs that actually compare the cost and the benefits of this drone to the tools we're already using today.
Which kind of leaves us with this one big final thought. We live in this world that's always pushing for more complexity, right? More power, more features, more everything. But this tiny little drone, this seed, it reminds us that maybe we should be looking in the other direction. So the question is, could it be that nature's simplest, most elegant designs, the ones perfected over millions of years, actually hold the key to our entire technological future?